Hello, this is Microwave Journal Technical Editor Pat Hindle, and I'd like to welcome everyone to our Technical Education webinar series. This installment takes a look at Mini-Circuit's Smart Portable Test Equipment for ATE applications. Our special guest presenter today is Chi-Man Shum of Mini-Circuits. Today's presentation is approximately 45 minutes long, after which time we'll hold a question and answer session with Chi-Man. You can submit a question through the website at any time during the presentation using the Q&A box, and this is on the right-hand side of the presentation window. Please address your questions to all presenters, which is the default setting in the question and answer box, and they'll be addressed at the end of the session. Questions will not be answered until then, and we'll make sure we leave enough time to do that. This presentation will be archived and available for viewing later on in the resources section of the Microwave Journal website. Also, if anyone would like more details on the slides, simply click on the enlarge button. Today's webinar is sponsored in full by Mini-Circuits, headquartered in Brooklyn, New York. Mini-Circuits was founded in 1969 and operates multiple design centers across the globe, leveraging several core technologies including core and wire, microstrip, LTCC, and semiconductors to offer over 10,000 active products and serving over 20,000 customers. In addition to the company's rack and mount test systems, Mini-Circuits has also developed a family of portable test equipment such as synthesized signal generators, switch matrices, frequency counters, and power sensors. Portable test equipment provides quick and accurate test results without a big investment in laboratory equipment. When combined with application-specific software, these modules can significantly reduce test and time and increase production throughput, and all are equipped with built-in user-friendly graphical user interfaces. These modules used in both R&D and production are fully compatible with 32 and 64-bit Windows or Linux operating systems, as well as LabVIEW, C++, Visual Basic, and .NET software. Today's presenter is Chi-Man Shum. Chi-Man is currently the Worldwide Portable Test Equipment Applications Manager at Mini-Circuits, where he leads the product introduction and marketing of smart power sensors, frequency counters, I/O control boxes, switch matrices, synthesized signal generators, and rack-mounted test systems for high-speed automated production requirements. Previously, also at Mini-Circuits as the Applications Manager, he managed and trained the sales team in the promotion of signal processing components such as VCOs, frequency synthesizers, mixers, power dividers, and filters into both commercial and military applications. Chi-Man started his career as laser industry as a research scientist specializing in electro-optic devices with applications in RF communications. He holds a PhD in physics from Stevens Institute of Hoboken, New Jersey in 1990. So at this time, I'd like to turn the presentation over to Chi-Man.
Well, thank you, Pat, and thank you all participants. It's nice to meet you all online. Pat has actually done a very good introduction, so I just want to emphasize that some of the slides I might go through very, very quickly, as our portable test equipment product line has been out in the market for a few years. You might already have a lot of experience with a lot of information online. So for the particular information that's online, or which Pat has already mentioned, so I would not spend too much time on those particular slides. I would rather leave as much time as possible to address questions at the end, or particular questions for specifics of certain slide. The slide that you are looking at is called the It's basically the Smart PTE, the evolution. We started this portable test equipment line actually even way before 2007. But power sensor was the first product. Then we increased it to switch matrices, signal generator, digital I/O boxes, etc. The so-called first generation product, and the frequency range, as you can see, the sensor ends at about 6 gigahertz. The signal generator covers 250 to 4,000 megahertz. and the various configurations of single-pole double-throw mechanical switches with 100 million cycle lifetime. Then as the requirements keep coming in, we have expanded the product line. As far as the power sensor, it goes up to 8 gigahertz maximum at this point. We're still working on some of the newer versions. We also have the RMS version that can take multi-tone and modulated carrier data. The signal generator is a pretty hot item, which has been released about a few months ago. And there has been a lot of increase, and we're still catching up on a lot of the demands on the delivery. It covers 25 megahertz to 6,000 megahertz at a very reasonable price. The mechanical switch matrices, the boxes have expanded significantly. We have now one USB-controlled box that accommodates up to 8 single-pole double-throw switches. We also have the new single-pole 4-throw switches in one box. We have also moved into system integration side by using the existing quote-unquote desktop components that we have, as you see briefly in those two little photos there. We are going to expand into more details later on in the slides following. This is just a, I guess, quick summary of the various products we briefly mentioned. In the signal source section, we have the 2 signal generators, various switch matrices, which you will see later, power sensor, frequency counters, etc. The main difference or improvement of the SSG 6000 signal generator as compared to the 4000 series, as you can see, it's a much wider bandwidth. Dynamic range is still the same, 70 dB, but the frequency resolution is much better. You can actually do very narrow step size, and the harmonics is still extremely good in the minus 40 to 50 dB range. Quick look at the main control screen with a GUI. You'll see that we can have the main screen where you can control the frequency, whether with the rolling bar or the increments, or you can type in the frequencies, typing in the power, or changing through the scroll bar, etc. We can do the sweep mode, the hot mode that you can change the frequency by doing a sweeping at certain step size. You can also put in the particular point that you want to go through during the test, set your own dwell time. You can do the hot mode, where you can put in the particular set of frequency and power point, so you can actually change both parameters at the same time. You can also save this configuration, which you can recall later on. It's a convenient feature for production testing. The SSG 6000 allows you to set the output into various pulse mode, whether you can trigger it, let it be in free running, or just a square wave. You can also do two-tone IP3 testing, which we often do in the RF industry. We can, at this point, the GUI allow you to link up to 4 generators at the same time. Just a quick look at the phase noise of the new SSG 6000 generator. At the 25 megahertz, the low end, you are mostly looking at about minus 130 dBc per hertz. You can tell it's within the loop band with about 10 kilohertz-ish. All these data will be in the presentation that you can download later, so we don't need to dwell into this. In the middle of the band, about 3 gig, you are seeing roughly about minus 100 dBc per hertz. And at the high end, it's about minus 99. Actually, that might be a typo. I think it's about minus 90, depending on where you look at them. Switch matrices. These are just standard, off-the-shelf, so-called desktop components. They house the individual single pole, double throw, extra long life mechanical switches. One thing I do want to emphasize that in our mechanical switches, there is no springs inside. This is one of the major reasons we can offer extra long life capability. You see those little color dots. It's not very obvious, but hopefully you can see that. And one side is green, one side is red. We do have an LED next to each switch, so the LED color will change to red or green depending on which side of the switch that the switch is set to. So it's a little helpful when you're doing testing in the environment where you have many equipments. It will help the operator to see exactly where the connection is. We have this also for the single pole 4-throw switch. This is 3 switches in the box. We can also handle more switches in a box as you requested later on. This is just an older photo showing you the details. We also have the temperature control cooling fan, which will turn on as we detect a certain temperature when it's warm enough when this will be turned on. So you can feel free to use the switch 724 without stopping it. So this is one big advantage. A quick look at the main screen. It's a GUI that we provide with all of our PT equipment. We have, other than this particular one, is a 4 SPDTs in a box. So we have all the 4 switches here. When you click the button on the top here, you will go from de-energized to energized, meaning you will switch from port 1 to port 2. And notice that all the switches are absorptive in nature. And as you go from de-energized to energized, you will also see the bar goes red. So on the screen, you can also see the state of the switch. And on top of that, we provide you with the LED indicator feature. There are many different configurations you can use for these switches. We'll just list a few of them, such as you can use it as a single pole 5-throw, single pole 4-throw, and a single pole double throw, etc. By just clicking one of these buttons. You can also do your own settings by using the user sequence. Let's hope we have a slide for you. Yes. So this one is one of the standard configuration of using it as 2 single pole 3-throw switches. These are the so-called software cables. So it will tell the operator you will need to connect port 2 of switch B to the COM port of switch C using external hand flex cable that we will provide. They are also DC 18 gigahertz, very reliable. So now you have separated the 4 SPDTs into 2 sets of SP3Ts in this particular configuration. And with a simple click of the buttons, you will change in this particular screen. This set with the B and C is taking the signal from the input to the output number 3 as shown. But you can just, with one click of the button on the GUI, you can change these settings. And certainly you can do your own GUI using your own software like C#, C++, VB, etc. This is under the user-defined sequence settings. It's just a convenient feature that we provide you with. You certainly can do your own GUI design. This particular one allows a user to set up multiple steps, which in this particular case, we set up 4 steps. It's no particular meaning. We'll say step 1, all switches are in COM to 1 position. Step 2, we want switch A and switch B to be flipped to COM to 2 position, just like in the screen here. And step 3 is some other different configurations. You can set the dwell time of each step because you may have to do some measurement outside and you want the switches to stay at that stage for a certain amount of time. You can also include your executable program into this link here. So once you click the continuous mode, you will see the switches going through the cycles as you wish, and you can keep track of the number count right here. So that's actually very good if you can set the counter and then leave and let the program do the job for you. This slide shows the latest single-pole 4-throw mechanical switch that we produce, which we have installed into this famous blue box, and we call it a USB box all the time. It's also a DC to 18 gigahertz single-pole 4-throw switch, very low loss. Isolation is in the range of 90 to 100 dB, which is very useful for a customer doing radio testing where they need very, very high isolation between the adjacent channels, etc. It's also absorptive in nature. LED always come with the display. Typical performance data of the switch, depending on where you use, what frequency you use it at, the through loss of each switch is very low, typically in a quarter dB or below for most applications in the wireless world. As mentioned, the isolation is extremely high, which is a very, very useful feature. This is how the GUI looks, and that's how we had it designed. You can certainly design it in a different way. Very simple. You click this button, COM to 1, you will show that you're connecting from the common port to output 1, or common port to output 3, or disconnect all of them. We have many power sensors on the web. You would find all of them. I just list maybe half of them here. We have 50 ohms version. We also have power sensor that's geared for 75 ohm applications. All these are listed on the web with detailed specs on there, so we don't need to go through the details of the power sensors. So up to this slide, we wrap up so-called the desktop components version of our PTE product. From this slide on, I will show you 4 or 5 examples of what we have done in terms of using our own desktop components to put it into a system that customers use for the applications that they have created. This particular one is a 2x10 port switch matrix, which is a very useful product, such as a VNA extender from 2-port to 10-port. The switches in themselves all work from DC to 18 gigahertz. The ultimate RF performance, it depends also partially on the amount of cabling inside this big box, because they would certainly limit the performance of the VSWR. It depends on how tight the performance you need. And the insertion loss, return loss, all depends on the amount of cabling. Let's take a look at the generic schematic inside. So when you come into this box with the 2 inputs, so-called the P1 and P2, we have 2 1x10 switch matrix at the front end. And then we have a bank of 1x2 switches at the output. So with this configuration, we can create a crossbar configuration which allows the input P1 to be connected to any one of the output 1 to 10, and the other port, which call it the return port, can also be connected any one of the remaining 9 ports at the front end. There are many different applications with this box. A particular one for the applications that we had, this is how the customer use it. They can connect up to 5 2-port DUTs at one time. The advantage of doing that is they can hook up 5 DUTs, and their test protocol can finish a particular test for one parameter and for all 5 units and then switch to the next parameter, etc., etc. So their program can finish all the 5 units at one time instead of one at a time. This is how the simple GUI looks. Again, this is the GUI that we use for testing the functionality of this particular box. So whenever we ship a product to you, we will always provide this basic testing GUI so you can do a quick test of the box without writing your software, so you know you'll receive a box in a healthy state. Such as in this case, we will give you a GUI that allows you to make a connection, let's say from P1 to port 3, P2 to port 8. You just do this 2 selection and click connect, and that's what the GUI will show, and the corresponding LED light will also appear, such as on the screen. We have chosen P1 to 3 and P2 to 8, and this one will be P1 to 5, P2 to 9. And all the other not connected part will be all grayed out. Some typical performance data showing the isolation performance of this switch box. Next product. The reason that this product is shown is not that this product is a very complicated one, but rather we want to show you that we will do this integration product based on the customer's interest. It can be very simple, it can be very complicated, but as long as it fits the customer requirement in this particular case, the important thing to the customer is they don't need to hook up the external power supply, then they don't have to hook up the external USB control and have all the amplifiers and the switch matrix all hanging and in the air or on a test board, so they can just grab this rack and move it around quickly. So that was the reason that they requested this to be done, and this is all based on the catalog items, the ZVA 183 amplifier and the 2 1x2 mechanical switches. And we can usually do this equipment with between 1U to 6U height, depending on the complexity of the job. Typical specification, which is based on the parameters of the ZVAs and the switches. Another configuration based on customer request is using our single pole 4-throw switch. So the question started with, can we actually put 2 of the single pole 4-throw switch in the blue box? Then the conversation ended up, they actually wanted 3 of them, and the rack mount solution is the most desirable, so that's how we did it. We can accommodate more than 3 of the SP4Ts in this switch box. Each one of them is operated independently, so that's how the GUI is made for this application, which you can control each one of the single pole 4-throw switches independently. If there are applications you do want to have a more than 1x4, you want a 1x16, a 1x32, etc., that can also be done. You have seen this test data, which is the performance of the mechanical switch by itself. It's applicable to this box because there is no interconnect between each switch. Another one product that we did for a customer in the telecom industry, again, there is no particular additional design required. The customer wanted the convenience of having the ability to use plus or minus 48 volts as a telecom industry standard. So this is the convenience we're providing to the customer. We turned this thing around in barely 4 weeks. We delivered quite a few of them. So that was the big thing. It's also the service and the delivery. So customer does not have to do their own design to get the rack and then make sure everything is mounted properly. So they leave it to us to do this job for them. High power signal source. Everything is using the components that we have. The signal source itself can handle more than this frequency band, but the high power nature requires a special power amplifier design, so this is why it's limited this particular box to 800 megahertz to 1,000 megahertz, giving out the 100 watts output. Now, what is really the use for this one? There is an application behind this thing. First of all, I show you a generic block diagram of this design. It's pretty standard. I'm sure many of you know this kind of design is a upper double-decker design. That's why you can see only half of it on top just now. With the power sensor here is to monitor the power. The important message for this particular design is the application is for a client doing burn-in for certain RF components. We also supply together with this HPG13 box a splitter matrix, 16 ways, that can handle the power. So we can also daisy chain those 16-way high-power splitter matrix so customer can expand it to 32 or 64 channels, etc. So the big deal about this application is now the customer does not need to have 32 or 64 signal source, which is expensive, but rather they get one high-power source together with our high-power splitter matrix that will give them a multi-channel tester, which is what's behind the big deal of this particular application. And that's the reason that this application was made. You might or might not have seen this. This is a particular 5-port tester that we made for the semiconductor industry. Particular application is to test some semiconductor-based 2-way, 3-way, and 4-way splitter and couplers, etc. The important part of this job was the customer didn't have to spend a lot of money to acquire the other brand name network analyzers and other things that will cost them a lot more money if they have to do that. And because of the lower cost approach of this box, they can afford to leave the box at particular test station without moving the equipment around, so they can just set it up, leave it there, and because the cost burden is reasonable enough, and then because the speed of the testing is extremely high, so they can actually improve the throughput, and by gaining the time over the course of just 1 month, the amount of labor time saved justified the purchase of this box. We'll take a quick look at this test data. The particular, because this is for production test, not for R&D, so the performance of the device and the test is already pretty well defined. All they need to do is to take 3 particular test points. In this case, it's at a 1.8 gig, 2 gig, and a 2.4 gig. At each data point, there are 9 parameters or 9 test data because it's a 4-way splitter in this case. So you see 4 insertion loss, S1, S2, S3, and S4. And then there are 5 isolation tests that's needed between 1, 2, 1, 3, 1, 4, 4, 2, 4, 3. 9 data points per frequency, 3 frequency points, total of 27 test points. The typical test time is about 650 milliseconds. As compared, which the customer has done their own analysis when compared to using the other standard network analyzer equipment. it took them about 1.62 seconds per unit, even with the robotic handling. When we say this, we do not ever mean the more expensive equipments are not good. We simply try to customize the solution to do exactly what the customer needs for the particular application. So in case now they don't need to spend extra money to invest in some of the capital equipment, this will be a great alternative solution. And basically, these are all the basic material I like to present to you. Certainly, the purpose of this presentation is to give you the idea of what we're doing, and we would welcome any questions and inquiry that you can send to us later on through email contacting me, and I can address as much as I can with the remaining time. And the applications is really based on what you want to achieve. We believe if you can do that, we can certainly do that probably with a more efficient production method. So we rely on the input from you so we can work together to create a solution that's a win-win for both of us. So at this point, I'll leave the floor back to Patrick.
Yes, great presentation, Chi-Man. Thank you very much. We have a lot of questions here, so we'll get started. Regarding the signal generator, how do you generate low RF levels like negative 100 dBm?
No, we don't. At this point, we can only go down to minus 60 dBm, but we also have a product which I haven't shown here, which is USB-controlled digital step attenuator that will work up to 6 gigahertz, and we can provide up to 90 dB attenuation. So with a combination of the two, we can certainly achieve what the customer had asked for. And again, I would welcome the customer to send me his or her question through the email shown here on the screen.
Okay, next question. I use MATLAB and Python for my applications. Do you support these software?
Yes, we do. We are aware that the basic software that we had already listed, like C, C++, Visual Basic, LabVIEW, etc., is not enough. So we have had already customers using Python version 2.7 and MATLAB, I think, version 8 or so. So we have been working with them. So if you don't see the particular DLL online, please just write to us. And in the meantime, we are creating a new programming handbook, and hopefully we can publish that in 2 months. So there is a lot of new information that we are preparing, but please contact us.
Okay, great. Next question. Does Mini Circuits provide equipment for amplifier burn-in applications? I think you mentioned that previously.
Oh, that's wonderful. Yes, I did. That application, let me refer back to what slide is that? Let me try. Oh, this one. This particular client wasn't doing amplifier, but the idea is they can do burn-in, and that's external to us. They can use it to test multiple components, whichever they like. Can be amplifier, can be other active components. So we pretty much have that answer, so please contact us.
Okay, and this may depend on the application, but how long does a typical custom test solution take to provide?
It does vary. I can only speak for what we had done for the last 12 months. I suppose the question may be referring to those rack mount solutions. We had done things. Typically, this is what happens. When we receive an inquiry, we can review it and reply, I would say, within 3 to 4 days with a preliminary proposal and budgetary quotation. Once the customer likes it, then we will finalize it and send the customer the outline drawing. Here is the block diagram, how we would build it. Once they agree, we had experienced to turn around the first box for them to approve within between 4 to 8 weeks. So it depends on complexity of the job.
Okay. And kind of related is typical lead time for a USB switch box and signal generator.
I would assume the question refers to those blue boxes, so-called quote-unquote desktop components, and we typically keep them on stock. But once in a while, we might run into situations, even keeping 20 on stock does not satisfy the market. So we might still need probably just 2 weeks, if that much time. So those blue boxes are mostly in stock all the time.
Okay, and I think you definitely can answer this one as we were just in China. If I purchase a portable test equipment and use production facilities in China, how do I get service and support?
You are certainly right. That's one of the reasons I went there, and I'm glad that I met with your crew there. We do have associates and facilities that's in various cities in China, in Beijing, Shanghai, and they all equipped with the technical capability to address questions from customers if they run into any service issue. So the answer is yes. We will be able to service the customer if they have any questions. And not only in China, we also have your office in Europe, which we will be developing and announcing soon. So we do have worldwide technical service capability.
Okay, great. And next question, does Mini Circuits have 50 and 75 ohm RF cable testers?
As a matter of fact, we are building a product for a client in the cable analyzer industry. So the answer is yes. We probably should be announcing the product sometime in June. Yes.
Great. Yeah, you guys are always adding new products continuously.
Yes.
And there's a couple USB related. Are there any other interfaces besides the USB available?
We are aware that the industry does like to see such as the Ethernet control. We are doing some work right now. I'm not sure if I can say we can start entertaining the inquiry in 2-3 months, but that is our goal. We have a work plan to review this Ethernet control capability in about mid-June or July time frame. We currently also can handle RS-232 in some products. But again, if the customer has particular inquiries, please contact us.
Okay, and another one, it says you have up to 8 SPDT in a USB box. Do you have higher switch counts? They're looking for like 12 to 16.
Great. When we go beyond the 8, it will make more sense that we'll start putting them into a little metal box or rack mount box because of the availability of the front panel space. So the answer is yes. We build all this custom design on demand and daily. So there is no concern. Just send us an email.
Okay. Is there any particular reason for the 2x10 port switch matrix having specified a frequency range of 8.5 gigahertz?
Great question. I think I sort of touched on that a little bit. I know that question would be asked. Number one, that was based on the customer's applications. The application requires a certain specifications up to 8 or 9 gigahertz. And because the application has very, very tight return loss requirement that require us to do some impedance matching. So that is the reason that it was specified that way. But the switches itself all work to 18 gigahertz. It all depends on the specifications required.
Okay. Another question is, what is the switching speed for the USB switches?
That's controlled by the USB electronics. I believe in most people familiar with digital electronics would know, it's certainly in about the 15, 20 milliseconds time. It's all depending on handshake of the USB.
Okay, great. I think we've gone through all the questions. There are a lot of good questions there, and you answered them very well. We appreciate your good presentation today and your presence in China last week. And we had a good show at EDICon in Beijing, which was great. And I'd like to thank Mini Circuits for supporting this webinar here. And any closing remarks?
Well, I appreciate the opportunity, and again, the purpose of this presentation is just to let the industry know that we have a lot of great service, and the flexibility is the key message in this presentation. So please feel free to send us your inquiries, and we'll be more than happy to discuss with you.
Okay,
and
excellent.
Thank you for
Thank everybody for attending today. Bye.
Thank you.
Ladies and gentlemen, that concludes today's webinar. You may now disconnect your lines.